In this lesson, we will explore the possibilities of using recursive functions in animation built using the GSAP library. The term recursion itself is used in various specialized fields of knowledge, from linguistics to logic. Recursion occurs when a thing is defined in terms of itself or its type. Recursion can be compared to a matryoshka doll. The first doll is the largest. Exactly the same doll is removed from it, but smaller. And this process lasts until you reach the last doll, which interrupts the cycle. In programming, a recursion or a recursive function is a function that calls itself. Let's look at an animation example built using recursion. We have this ostrich that will move through teleports. The first click of the left mouse button determines the location of the red teleporter. All subsequent click the location of the blue teleporter. The animation doesn't look complicated visually, but this example has interesting logic and can be a rewarding experience. Let's get started. There are two files in the source code of this example, HTML and JavaScript. The already familiar HTML structure for you. SVG container styles. The container itself. Our ostrich is a GIF image containing two frames to display dust from under the feet. Of the sizes, only width. Height is determined automatically. The ID runner will be required to specify the target of the animation. Finally, there is the script file, to which we go. There will be two functions here. The first one, which tracks the left mouse button click, and the second recursive function is move, to animate the motion. We'll start with variables. Let's declare a variable to access the animation container. As the default settings, we will specify the time and the linear view of ease. In addition, we need variables to store the position of the teleports. And at the same time, they will determine the initial and final values for the trajectory of the ostrich. You may have already noticed that the trajectory will not always be linear. The variable portal type will help you to find out which of the portals should be displayed when the left mouse button is pressed. First, we'll take a look at the move function. Since it is recursive, it contains a call to itself. The parameter is the counter of the ostrich's movements, which is constantly increasing. Recursive calls will stop as soon as the counter exceeds 9. The body of the function uses the to method to create the twin. Animation object and target values. As soon as the ostrich reaches the end, you need to teleport it. For this, we use the set method. We have finished with the animation of movement and teleportation. It remains to figure out the placement of the teleports themselves. The body of the function considers two cases. When there are no teleporters yet, portal type is equal to 0, and other cases. At the end of the first case, we make a note one teleport is already installed. Accordingly, in the else block, we make a note that there are already two teleporters. First, we remember the location of the cursor. After that, we'll use the inner HTML method to add the red teleport image to the SVG container, which is contained in the pod2 SVG file. This image has a white background to the left of the teleporter itself, which will hide the ostrich when it appears. In the else block, we first place the ostrich in the red teleporter. Then we check, is there already a second blue teleport? If it exists, remove it using the remove method. Next, we remember the position of the cursor and add the blue teleport, which is contained in the pod1 SVG file. In this image, there is a white background on the right. At the end, it remains to call our recursive function. This code is not the only way to solve this type of animation problem. And you can build multiple alternatives if you wish. The last thing I would like to draw your attention to is the behavior of the ostrich when moving the blue teleporter. Try to make your own conclusion of why this is happening. And I'll give you a little hint. The length of the pose is different in different situations. This lesson came to an end. In the next lesson, we look at animating filters.